I will introduce you today to custom RxJS operators. My name is Trzesniewski. I'm a senior front-end developer at Scala C. You can find me on GitHub and Twitter, and I will post, or organizers will post the slides afterwards. So let's begin. I will start with some introduction to what observables are, but it will be brief. So what is an observable? You can think of it as a stream of data. If you've developed before with promises and you look at observables, it feels like it's a promise on steroids, but it's much more than that. And it's basically a function that ties two objects, an observer of data and producer of data. And the way I like to think of it is that it's basically data delivered over time. So we have those data, and where do we put operators in here? So what is an operator in RxJS? It's a quote from Ryan Chenke. So operators are the things you put in front of your stream before getting values out of it. So you can think of it as a I like to think of a coffee example. So you've got your beans, you have to put some grinding in front of it to make it usable for your coffee machine. Then you have to add combine in some water. Then if you like, you can add some milk. So those operations might be considered as operators. And we have plenty of them in RxJS already. So I divided them in few groups. First is filtering. And we've got filter, the bounce, throttle, which are used most commonly. You can do like you use them mostly in like type heads and stuff like that, so you don't kill your backend with queries. Then you can transform your data with maps. The map is basically what an array has built in. You can scan, which is similar to reduce on array, and switch map and merge map are higher order transforming operators, which I covered in one of my previous talks. So if you are interested, you can. I invite you to Google it. And there are also combining operators. So this you could think of as you've got your stream of beans and you've got your stream of water, and you combine them together to create a delicious drink, which is coffee. There are many different operators which does the combination in different ways. I will use zip in this presentation, but we'll come to that later. I'm breathing pretty heavily. And there's the last thing is creating. So you can create something like similar to set timeout and set interval. So you can set a timer which will emit a value every certain amount of time that you specify. Interval is pretty similar. And you can create observables out of single values or arrays or sets and etc. with from and off, or use the most low-level operator, which is create. And let's visualize how the operators actually work. So at the top we have a stream of 9 values, and we are for some reason interested in only the ones that are, when divided by 3, it equals to 1. Modulo 3 equals to 1. So we can apply a filter operator with a predicate. It works exactly like an array function. And the cool thing about operators is that we can chain them. So right after we apply filter, we can apply another operator. In this case, we will apply a map, which basically multiplies, in this case, it by 7. And every operator will create another stream slightly transformed. So to see how it works in code, so we've got a timer which emits a value every second, like it will emit 1, 2, 3, 4, and etc. And we've got a result which we will transform somehow from source. So to apply our operators, we use a built-in from RxJS, I think 5.5. We can use pipe function and feed it with our operators. So like I shown you on the example, we can just chain them. First filter, then map, and we are given the result stream. But okay, so there are over 100 operators built in RxJS. I think it's currently 103, but it grows. So do we even need custom ones? It feels like there's already enough. But we can benefit from simple, even the simplest things, like extracting the logic of the operator that is already there to make it more readable for us. So, for example, we don't want to use map, but we want to use multiply. So it's more descriptive what we want to achieve. So we can create specific operators based on existing ones to make it more applicable to our code base. And in this way, we can also extract multiple operators so that we use a lot to create one custom operators and to reuse it across our code. And I will show an example of that. So simple changes, like simple custom operators like that, will allow us to clean our code base a bit and make it more readable for the developers to come. And finally, we can, if we feel really lucky, and we can create missing pieces ourselves. It's really rewarding. It's hard to find a use case for something that is not already there, but it is also fun to find some things that are missing. So what actually are operators under the hood? So operator is basically a function, and it takes an observable as a source observable as an argument, does something with it, and returns another observable, which is emitting a transformed or filtered or combined or etc. values. So the TypeScript definition of that would be operator function is basically a function from one observable of type T to an observable of type R, because the types might be different. And straight out of it, we can see that an identity function is already an operator. Not particularly useful, but it's fun to know that it can be as simple as that. So let's put that in real life, and how do we create those custom operators? So we can, as I told you, we can extract the common use cases, like for example, filtering null or truthy values, and it can be cumbersome to type always filter and provide it with a predicate value of value is not null, or value is negating twice the value to see that is truthy. So we can create a custom operators to make it more clear in our code base. So we can create a not null operator, just assigning a filter to it, because filter is already an operator, so we know that it works out of the box. And similarly, we can create is truthy, which will check also for nulls and other false values, for undefined and all other false values. So that's cool, but that's pretty basic. We can also create parameterized operators. Like I told you before, we could create a multiply, which we provide with one number, a multiplicator, or a power function, which will calculate the power of our stream. So it's pretty similar. Here we just, instead of assigning an operator right away, we create a function which we, after we call it, will return us an operator. So here we provide it with a multiplicator, and it returns just a map function, a map operator, which does the regular thing. But everywhere in the code base we can use multiply, which is more descriptive in this example. And similarly, we can use a power function, and again assign a map operator to it, and be happy that our code base is cleaner. So the second and maybe more useful use case for the operators is grouping multiple operators into one. And the basic recipe for that is that we create a, like in the typing, we create a function from source to result. So we take a source and use a built-in pipe function to chain our operators and create something that is useful to us. So to come back to a bit to an example from the beginning, we could extract those two functions, filter and map, into one operator, in this case odd values times 7. So we know that we will get only odd values and then multiply them by 7 using only this operator. And this is just a function that takes a source stream of numbers and pipes it through two built-in operators, and that's all it does. So it is also pretty simple, and everyone can benefit easily from that. And something that I used a lot in when fetching some from the API some data is extract data operator, which does the when we fetch some data, we want to know that it's not null, that it's already fetched, and only when it's fetched we want to actually emit a value. So we can transform our response in and create a custom operator for that. So first we check if the response is actually truthy, because if it's not, then we cannot access any properties inside, like data here and loading. Then we filter our response by a loading indicator. If it's still loading, we don't want any data yet. And after it's finally loaded, we can map it to our data and show it in our user interface. So this is something that I used in the real life project. It's pretty slick. Okay, so we've covered the basic examples. Now let's go a bit more deep into the subject and create something from scratch. So a basic recipe for creating an operator is we start with a function from source to something, and then we can create a new observable which takes an observer in which we will push our data in, and then we subscribe to our source, and we can do something inside of the next error and complete callbacks. And at the end, we should put something to our observer, so the resulting stream is actually emitting something. So this is a recipe. Let's apply it to something. So we can create kind of a custom map operator, which does basically what map does, but we need to learn somehow how to work with that. So we take a project function which does the mapping on an object, and in our subscribe, the only thing we do is put it in our next callback and transform the value of x into something that we want to. So creating a custom map is with this recipe is pretty easy, but makes no sense to do it this way. So let's create something more useful, and now it's time for the live coding. No worries, I will make it bigger. Can you see it? Okay, so I didn't explain what I want to create. I got lost, sorry. So there is an alternative recipe for creating a custom operators, which is more abstract, let's say. We can use, we can take our source and use a lift function, which basically creates a new observable with an operator applied to it. So this is also our custom operator, which will implement the operator interface. And the operator interface is pretty simple. We just need to implement a call function. So it's basically the same concept as we did earlier, but more wrapped in some abstraction. It might be useful if we are creating some more complicated operators when we need to manage our internal state somehow, and it might be easier to do so. And then in our subscribe, we just create a subscriber, which is basically an object that has next, error, and complete functions on it. And we have an... Oh, it's misaligned. And we can create such an operator and implement the next function. The rest of that is implemented right away by the subscriber. So here we just overwrite a next one and use the project function to push the values to our destination. So now we can create another operator from scratch. This is something when I was like playing with RxJS, it seemed pretty useful, and I couldn't find it in the currently implemented operators. I called it buffer delay. So basically, we feed it with some delay time, like we do with other delay functions. So it will be a number of milliseconds. And if in the given time more values are emitted, they will be buffered and evenly emitted with the delay time between them. And if the value is emitted after a specified delay time, it will be emitted right away because it's not, we don't need to buffer. So you can think of it as a dam on a river, and we only open it, let's say, every hour or something. That we don't want to flood anything after the dam, but we want all the values to be delivered at some point. So let's implement it. So I here created a scaffolding for that. This is basically an empty operator which does basically identity, and we have a small example showcasing that. So the first one is already implemented. I will show it in the moment. And the second and first are the two ways to implement our buffer delay time. So right now on the left side, we will show the clicks right away. And on the right side, we will show the result, which in this case is the same because, as I told you, this is just an identity operator. And how it should look like, let's see on the first box. So if I click once, it will be emitted. If I click second one, it will be emitted. But if I click like 3 times in a row, it will be delayed. And again, we can feed it with more data. So let's try to do that. So the way I approached it is that I thought of is that we can create kind of another stream that will notify us that we can pass the values through. So it's like this dam that basically opens whenever the specified time is passed. So let's create it first with typing is hard. Ready? And I will implement it as behavior subject just so that we can push to it new values. And in our code base later, I will use it as an observable, so I will strip it off from the subject methods and create isReady operator, which is ready as observable. So because behavior subject is both an observer and producer, and it's, in my opinion, it's cleaner to have a separate have them separate. So okay, and here actually we are interested only if in the values that are true. So I will filter is truthy. I think I didn't implement it. So value like that. Okay, so now we've got our isReady function. What can we do with that? It's initialized with true, so the first value is always can be emitted, and this is where the zip operator comes in place, where we which is basically waiting for the both. For all of the observables that we provided with to emit, and matches the first emission with the first emission of everyone, and then waits for the second and third and so on and so forth. So let's use it. And we can feed it with as many observables as we want to, but we are interested only in source and our isReady function, isReady stream. Okay, so zip operator returns and will emit values in an array. So we need to map it again to our source because this is the only thing that we are interested in. So it will emit source and isReady, but we are only interested in S, and so we can just map it. Why is like always map? Too many. Okay, so we have to map it to match. To return our source again, because this is the point where source and isReady are already brought together, and we are not interested in the isReady anymore. So if we go to our example, and I think it already compiled. So if I click once, it will emit, but if I click again, it will never emit again because the isReady is not emitting any more values, so we cannot match them with the 2, 3, 4, etc. So we need to somehow let the isReady stream know that, to feed it with some new values. So to do that, we've got a tab operator, which is basically something that we can perform side effects with. So Here, we can just use the basic set timeout with the timeout of time, and here push to our ready subject. So we push ready, next, true. So now, after a specified, after the value is emitted, we will wait a certain amount of time, and after that, the next value can be emitted. So let's look if it works. So I click once, it works. I click twice, it works. I click 3 times, 1, 2, 3. It waits. So it's just as simple as that. Just zipping 2 streams together to get the result we want. And I want to show you second way of doing that with the second abstraction using the lift function and then buffer delay subscriber. The only interesting part is actually the subscriber itself. So here it, for now, passes the value right away to the destination. But we want to do the similar thing that we did earlier. So we need to create a ready subject, behavior subject, true, private is ready. As observable. Why don't you work with me? I need this. Thank you. Live coding is always hard. Thank you. And then we pipe with filter, and just provide it with. Actually, this is where the identity function is useful. Instead of writing that, we could write identity. Oh, it even works. Okay. But here, we kind of lose the source, the reference to the source stream. We are only given this next function, next method as an interface. So we kind of need to move it back to our stream and push it there. So we need to create another subject, new. I remember behavior subject, null. This is annoying. Can you still hear me? Private source. This source as observable, and here we pipe filter, or even not filter but not null. I've got it implemented already. So you can see that we can already benefit from using our custom operators that we create, that I've shown you in the presentation. And here we need to push to this source next value. Okay. But now nothing will happen because as I haven't told you yet, observables differ from promises in a way that they are lazy. So unless we subscribe to it, nothing will happen. So we need to create our subscription. We can do so in our constructor and subscribe to our source. Subscribe. With okay, with this Destination implements a subscriber. Where is that? A subscriber interface, so we can just pass it right away instead of creating this proxy object with next error and complete. And before we feed it right to our destination, because now again it's basically identity, we need to do some piping. First, zipping. IntelliSense is not always helpful. Zip source with this is ready, and mapping it back to our source, and tapping. I need to import stuff. Okay. And here we just set timeout. So this is basically using the same logic as we did before, just in a slightly different syntax, let's say. And here we need to use this time colon, semicolon, and this buffer ready. Next, draw, Bach. Hopefully it works. So I click once, it works. I click twice, it works. 1, 2, 3, it waits. Awesome. 1, 2, it waits again. Okay, so this is basically what I wanted to show you. For the time being, I think it's enough. Let's summarize a bit. So we've learned that we can extract the common use cases with simple custom operators to create more descriptive ones with a more descriptive name, and we can also chain our operations, also cleaning up our code base and making it more reusable. And if we really need to, we can create our brand new custom operators from scratch, like we did with buffer delay, and we can use our imagination to create different ones. So now we know how to harness the power of operators. We've got the power, but remember, with great power comes great responsibility. So please don't overuse it. And as a invitation, test it. I will talk about testing observables in 2 weeks in Warsaw. So if you want to visit, I really invite you to. Thank you.
Thank you, Chris. Please, questions in English, please. Chris, it is true that Poland people understand Ukrainian a bit?
Yes, I did understand you in a bus a bit.
You so can try to ask in Ukrainian, but better in English. Do you have question, guys? Hey. Yes.
Do you use RxJS mainly on front end or back end?
I've used it in Angular project using GraphQL, so that's why I've shown you this extract data as well, which was useful there. But it is framework agnostic, so you can use it with React, with Vue, as Natalia likes to use it, I think. And you can use it also on backend, but I'm not a backend developer, so I haven't used that.
Does the whole team, your team, I mean, use RxJS? Is it okay in the team?
There is a bit of a barrier up front. I am aware of that, and I might be too deep into that subject that I sometimes cannot understand why people don't understand it. But I think after like let's say, a month of working together, is going better. We can ask this question to Natalia, because she was the one that joined me 2 years ago on the project, and Natalia Tepluchina, and we worked together.